So I will now explain to you how the Alibaba cave works and how it is a good example for a serial knowledge proof. As you can see, we have two persons here, the green one and the pink one. The green one is the verifier and the pink one is the prover. The prover wants to prove that she can come out both ways, A or B, but without revealing the secret how to open the door here. And the verifier says a way that the prover needs to go through, but without knowing what the secret for the door is. So the verifier is not allowed to know the secret. As you can see, here the verifier is choosing a way, and the prover is also choosing a way. So now she goes down B, just behind the door. Now she's behind the door, and the verifier says the way she needs to come out. So she needs to come out the way A, but there's a problem. The door is between here. So she says the secret or makes the secret work, and she can go through this door to A. And at the end, you can see she's coming out the way A, as the verifier wanted her to, but without revealing the secret how to open the door here. And that's the basic understanding of zero knowledge proofs. So now I will explain to you how our project Arduino is connected with the zero knowledge proof concept. As you can see, on the left we have a code snippet from our code. The code is later explained by Mark. And on the left we have the cave of Alibaba. That's our zero knowledge proof right here. We now take the color green and mark our user input. That's the input with the pressed with the buttons on the Arduino. Later, that's coming later in the video. And we mark the path that was predefined by our Circom and Snark.js. And we mark the person here too. That's the verifier. We are this person in this case. And there is the prover. That's the Circom in this case. As you can see, we did the input that we choose 3 times the right path. So we did this one. And all our paths were here 3 times this way. The predefined path, it was 1 time this way and 2 times this way. As you can see, that's not correct. We did 1 path wrong. So in this case, this would be a false proof or not proven because it was 1 time wrong. And this is more of a representational example. We have another program, another mode of the Arduino that's a bit more complicated, and this one is more for showing how it works so that people can better understand the concept of it.
In regards to the underlying implementation, you have this circuit, which is coded in Circom. So first you have the input path and the user input. Those are the randomly generated path and what the user entered in the Arduino. Then you have a matching array, which just simply compares each subset of the matches to make sure that every path matches. If that's the case, the output will be valid. However, if there is one mismatch, the output will be 0 for false.
Now we have a look at the second program that our Arduino has on it. It's about a password that you can input with the 2 buttons on the Arduino with 0 or 1. And that's the main principle of zero knowledge proofs. As you can see, above we have the Alibaba cave again, and the person that chooses the path automatically, and the other person, the verifier that chooses a path where the violet person has to come out. And the password is used to unlock the door in the back. So the verifier is not allowed to know the password. So we input the password that the prover can use to open the door. And as you can see, the only thing that the verifier can see is where the person comes out, and that's hopefully the way that he said. So as you can see, there is a hidden password that we can give to open the door that the verifier doesn't need to know, and he only knows the bit that comes out, either 1 or 0, so either left or right way that he said. So it's a good way to prove that we can see that the person, the verifier, doesn't need to know the password, but he can still believe or still verify that the other person knows the secret.
These are the rules that the password has to follow, where X, Y, and Z, as well as the underscore, are either 0 or 1, and the code checks if the X's have the same value as each other, same goes for Y and Z, and it also checks that Y and Z have different values. This would be an example for a valid password where X, Z, as well as the underscore are equal to 1 and Y is 0, and also Y isn't equal to Z. So here you see the circum code of the password validation. First, you'll get the input of the password, which will be a binary password of the length 8. Then you have the match array, like in the previous example, and you'll have the final output. Each match will check if the specific positions in the password follow the required rules. And if they do, each step will be 1. These will then be continuously multiplied. So if every step is 1, which means that every step is true, the final output will also be 1 for true. If there is one mistake in the password, the output of the whole circuit will be 0 for invalid. So now that you've seen how the Alibaba Cave works, we'll show you how the interactions between the user and the Arduino and the script look like. So on the right side, you'll see the interactions between the user and the Arduino, and on the lower left side, you'll see the output of the Python script. Before you'll be able to use our implementation, you'll have to properly configure the Arduino as is shown at the end of this video, and you'll have to install the necessary files as is shown in our documentation. So once you've set up your Arduino correctly, you'll be able to use it. I'll show you how to do that now. So first you'll have to connect the Arduino to your PC. Once you see it lighting up and displaying some random path, you can now start the script. You can now use the Arduino to simulate zero knowledge. So first I'll enter a valid path. That means the same path as is displayed here. So now that we've chosen the path, it will be verified on the PC, and since we entered a valid path, it will also be the output on the Arduino. Now I'll enter an invalid path, so we can also see that working. So now the same will happen. However, since we entered an incorrect path, we will also get that displayed on our Arduino. And now I'll switch the modes between path mode to password mode. This is done by pressing both buttons for 3 seconds. You see both LEDs light up, and then a message will be displayed. Once you see these 8 underscores, you can now enter a binary password. You can do this in whatever fashion you like. However, it must fit a certain circuit layout to be validated as correct. So now this was an incorrect password, and now I'll show you what a correct password could look like. So now this will also be validated. And of course it was a correct password, and thus the input is valid. And if you'd like to change back to the path mode, after being in the password mode, you can simply do this again by pressing both buttons for 3 seconds. Now I'll guide you through the steps necessary to set up our Arduino. First, you'll have to add the LCD display. We'll get to connecting that later. Then you can add the 5-volt power and the ground connection to the uppermost row. After that, you can add both of the LEDs, which will be lit up when you press the buttons. These are connected to 4 and 5 on the Arduino. Then you need to connect the cathode of the LEDs to grounds using a resistor. After this, we'll connect the buttons. First, we can take the ground connection and pull it into the lower bracket as well. Then we can add both of the buttons. Then we can connect the first button to port 2 and the second button to port 3. We can then connect the first button to ground with a resistor as well as the second button, and now we can see if this layout works. So of course you won't see anything on the LCD display yet, but we only want to see if the buttons light up. The left LED lit up when I press the left button, as well as the right button lights up the right LED. So that's functionally perfect. Next we'll add the potentiometer, which will connect to ground as well as to the 5-volt input that we have. Now we'll start connecting our LCD display. First we'll connect the ground pin of the LCD display to ground. Then we'll connect the VCC, which is the power supply of the LCD display. We'll connect that to our 5-volt connection. After that, we'll connect the output of the potentiometer to V0. V0 is the contrast adjustment of the LCD display. Then we connect pin 7 of our Arduino to RS. This input on the LCD display simply defines how the LCD will register incoming data. Then we'll connect our W read-write to ground. We simply connected it to ground since that is 0 and that is the writing mode, and since we will only be writing on the LCD display, that's the only thing we need. After that, we'll connect E on the LCD display. That's the enable, and this is also just to instruct the LCD on how to write things. After that, we'll connect pin 9 to our data pin 4. We'll connect pin 10 to our data pin 5. Connect port 11 to the data pin 6. And finally connect port 12 to the data pin 7. After this, we'll connect the anode and the cathode, which are the backlight. So we'll connect the first to the anode to the 5-volt connection, and we'll connect the second LED, the cathode port, to our ground. And once this is done, the code will work. The setup is done. The setup of the Arduino has been completed. We can now also test this here. So now you can see the LCD display is displaying left, right, left. So now we can enter this code as is. we'll see that we have chosen a path and that our input was sent to the PC, and now the script would verify it and then send data back to the Arduino, and this cycle would repeat itself.